Vi välkomnar nästa talare. Det är Claus Aasholm från Danmark. Danmark. Så varsågod.
Tack ska du ha. So welcome everybody to today's presentation. Some of you might know me from LinkedIn, where I'm roaming around a little bit. My career in this game started back in the middle of the teens, where I suddenly realized that the days of the Silicon Cowboy were over. I used to work for CEOs that carried a gun and a big stick and spoke the truth, but not anymore. Okay, suddenly we had suits, we had corporate candy floss, and then they just said, hey, everything is great, don't worry about it, on to the next investor call and things like that. So I took a break. I listened to 40 investor calls. Now it's 400. And those 40 calls, every semiconductor CEO said, we're doing great, we're gaining market share, and everything is up and to the right. And I was thinking, there's got to be at least one who's not had a great quarter. In average, they got to be average. No such thing. Everybody were doing great. And I realized the day of truth in this industry was over, and I began my business, which is called Semiconductor Business Intelligence. And what I do, I listen to all the calls, and I got corporate candy floss coming out of my ears. But at the same time, I go and check the numbers, and I check them against each other. And so basically, this is sort of my data sheet. So I had to be uncorporated in order to do this, because inside the corporations, there are good facts and there are bad facts. Good facts support the narrative of the CEO, bad facts goes against it. So please bring us good facts and happy data. And those days are over. I don't do happy data anymore. I'm more for the brutal, honest truth. So what you will see is that most of my work are in two parts. One is the fact-based data part, and the other is my opinion on top. Feel free to have another opinion, but if you want to challenge my facts, please bring some data, and we will discuss. Also, I'm not entrenched in a position. If we have new data, we have a new story. So, somebody says to me, but last month you wrote, and I say, yeah, that was last month, we got more data. So a year and a half ago, I started to see what I believe is the tsunami. In my data, suddenly it became very obvious that something was changing. This was not our normal cycle. There was something that I think was systemic, and I started to investigate this in bigger detail. So what I use what I call the market model. So this looks very complex, and you don't have to worry about that. All you need to worry about is that semiconductors and electronics is a network. It's a big network of supply chains. The only people who think it's simple are politicians. Do that, money here, embargoes, tariffs, and so forth. It is incredibly complex. And here you only see about 15 of them. But in total, I run 50 segments and more than 400 companies. So when I say I listen to 400 investor calls, that's not actually true, because that's like 10 weeks of work. So what I do is some of them I get the transcript and just browse through them. But in principle, I cover 400 companies. The reason I do this is that we can no more just rely on a simple number like WSTS. We need to get down into the weeds for companies to understand what is really going on in their market. Of course, you can buy 3-year-old Indian market research that shows, that you're gaining market share. And you say the company next door, you can buy the opposite market research that shows the opposite. You pick your research and everything that can support the story. And if you don't like the data, give them a call. They're absolutely flexible, okay? So this is the market that we're in, that people, it started with the CEOs talking about, happy news and happy data. But now it's deeply ingrained into many large corporations. So actually they're using it internally. So of course, I go against the stream. And today I'll show you a little bit of the things I saw and where it is today. And this data is very fresh. Actually, this morning at 5 o'clock, I was still working on the data. So you'll see that most of the data is up until the end of Q4 24. Some is up until the end of Q1 25. Couple of slides a little bit older, embarrassing, but true. So you'll see that this is absolutely what's happening right now. And I got a good idea of Q1 altogether, but it's not fully resolved. So one of the things when I use this network and I monitor the entire network is that you find out that it's a time machine. Okay, so there's some people that are forecasting. No, I'm not forecasting. I'm looking into the supply chain and see what's coming. Okay, so this is one of the things you could see here. This is the revenue of a company, a green company. About in 20, there's nothing obvious happening here. But if you look at the high headcount, there's something going on. Okay, and this is interesting in the semiconductor industry because you cannot get lucky in the semiconductor industry. It's impossible. You have to make a bet, and then you might get lucky. And this is a big bet. And what happened? This was the result. Okay? So would some of you have liked to know that what happened, in beginning of 20s, that Nvidia became a big company? I didn't call it, by the way. And even if I did, I didn't care because I bought Nvidia in 97. Yeah, I know I look younger, but that's how it is. But this is a good example of what is happening. So rather than just say, okay, we wanna just choose some facts that suit us, have a look into the supply network, find out what's going on, and is this gonna impact us? So a lot of the work I do are for corporations and companies that are asking the question, is there something wrong with us because we're not growing? The entire semiconductor industry is growing, but we are not growing. So are we bad or what? And the reason is you're probably not looking in the right place. And you need to make absolutely sure you're looking at the right place before you understand what goes on. And the simplest of strategy, as I see it, is 3 basic questions. And the first is, what's going on? That's what you need to base your strategy on. If you get that wrong, I'm not a great fan of your strategy. You might get lucky, but I don't think that's really possible. So, what's going on? This is WSTS. Some of you might know it. It's a trade organization, an industry organization that has been tracking the semiconductor revenue back from before I was wearing shorts. And they come out with a number every month that gives you an idea of where we are in a cycle. This number is updated right now with March that came out here last week. And, well, what do you think? It looks pretty normal to me. There's 4-year cycles in average. The last 3 cycles have been pretty accurate, even though we threw in, financial crises and COVID. But the cycle sort of adjusted in. So this looks pretty normal to me. Thank you very much for showing up, and hope to see you next year. Or maybe there's more. So this is what it looks like. So we are, depending on if you look at the monthly number, which is the blue, or the red number, which is the average annualized data, you can see that we are within 1.5 to 2 years into the upcycle of a 4-year upcycle. The next peak is right now probably estimated to be summer 2026. So most companies now should experience, something like 26% growth from the trough, or 13% a year, and should experience a good next year. And then, I have some that come up to me and say, yeah, well, who cares? Who cares about the semiconductor cycles? If you don't care, don't worry about it. Just go and do your thing. But we have an industry where there are good times and bad times to invest. So we have, first of all, an industry, if you look at the manufacturing, that's very capital intensive. And it takes time, from the check is written until the fab is finished, there'll be 2 years, which is also like why we have this cycle. So what you could see is you also need heads. And heads also take time. They don't just hit the ground running. Not the ones I've hired anyway, but that could be my fault. So you have basically a period of time where it's very, very cheap to invest. Unfortunately, that's the time when you have the least money. So very smart companies, they go like salmon, they go against the stream, and they invest when it's difficult, and they stop their investments when it's easy. So this is why the cycle is very, very important. And what I'm going to show you now is sort of my internal timeline of what has happened since I saw the first sign of what is going on. So it's a little bit of a busy slide, but I'll try and see if I can help you. On the top, we got the timeline. And some of the earliest events back in 2020 were related to China. Basically, all of it is China. Hey, you're not allowed to take photos. Okay, come on. Basically, everything about this presentation is maybe about China. So what you have up here is that US starts to sort of like limit technology purchases by Chinese companies. And later on, actually around here, the US military starts to realize that most of their stuff are actually made in Taiwan. And if China attacks Taiwan, then they can't fuel their missiles and everything else. Chris Miller had written a great book about it, Chip Wars. But this realization happened at the same time as the glory kid of the US, Intel, fucked up Intel 7. Okay, there's no other way to say it. Okay, they thought that they could do it without EUV, but they couldn't. So suddenly the military of the US said, "Ooh, we can't even get it from Intel." So this started this whole process that are now changing our industry. The China, can you say, bar up here is not new. Where US companies have trouble seeing outside the quarter. In Europe, we meddle around between vacations. But in China, they have decades-long strategy. And this one is several decades long. It's when they started screwing things together, they found out that, no, we need to get to semiconductors. That's where the value is. So that started the US reshoring policy. It had several elements. They started with the National Defense Act, became the Chips and Sciences Act, and then the CHIPS Acts that we are commonly known. But apart from that, they kept tightening the screw on what China were sort of allowed to buy. And the most important things are, of course, the expensive light and magic tools from ASML, which is also interesting if Europe gets into a trade war with the US, Yeah. Sorry, guys. Holland is shot. So what happened at the same time was that ChatGPT 3 started. It was not surfaced yet, but Nvidia and OpenAI were already working on it, and later on it became more visible. And that also had an impact on what I call the supply chain transformation, which we'll look on later, and then foundry concentration, because this all benefits TSMC. We had end of COVID. That created a demand reversal. I'm going to show that a little bit later on. And then, we saw the demise of Intel and Samsung. So in principle, the industry have been concentrating until Intel and Samsung failed. Now I used a better word, okay? Pardon my friends. But now it is returning again. So the industry is becoming very, very concentrated again. And now we have a new thing called Trumpnomics, Moronomics, or what you want to call it. This is horrible for your business. It's wonderful for mine. Okay, I'd vote for that guy any day because people are desperate for data to find out what's really going on. We don't see anything yet. We'll see something in a few weeks when Nvidia reports, and they have a large chunk of their business that goes to China that they're going to make a miss on. We know that already now. So let me just give you an overview of the industry. These circles are to size. So they're based on 24 data. And as you could see, the big, all in the middle there are the semiconductor industry. And these companies truly dominate the industry. These are huge companies. But if you look into the foundry bubble, you see TSMC dominates a lot more. Materials are not so big. You've got tools up here with two dominant companies, ASML of Europe and AMAT of the US. And then you got OSAT down here. But out here, you got a very, very big bubble. So these are the EMS companies or the ODM companies, depending on what, if it's Monday or Tuesday or what they're currently producing. But that's where all our iPhones, our PCs, and our, let me say it, servers are built. They're incredibly important for the entire industry, and you can really gain a lot of knowledge if you follow these guys. So let me try and see if I can zoom in a little bit here. So this is basically my supply network. And we have, of course, two equations and things like that. We have supply and we have demand. And there are three major drivers right now. Two supply drivers are everything that goes on in the US. So the subsidies, the embargoes, and tariffs are not impacting demand at all. Nobody buys one chip more because of the CHIPS Act money. But it really, really makes a big difference in supply. Because suddenly we're building a lot of factories. In the good old days, 2 years ago, we built a factory when we need it. Okay? Now we build a factory when we get free money. Okay? So it's a completely different dynamics than we have now. The other element is that it's probably no secret that China is building semiconductor factories. And none of these factories are changing any demand. But they're changing the supply situation quite a lot. Okay? So all of this does not really help the industry grow or any companies grow. There's fortunately a little bit another one over there called artificial intelligence, led by OpenAI in the beginning, and now there's, of course, a whole host of companies. This is the major demand in the industry right now. And it's the big cloud over everything we do. Because nobody can see what goes on beneath it other than, hey, something is growing, something is happening. So in order to dive down into a little bit more detail, we need to look into try to break the semiconductor up in a little bit more, manageable chunks. And now it gets really busy here, but the IDM is the traditional semiconductor company. In the good old days, you designed a chip, you just built it in the fab, and you sold it to somebody and made some money. And then later on, you'd invest a little bit. Later on, you found TSMC and Morris Chang, found out that it was horrible building chips in the US. Moved it to Taiwan, and suddenly you could do it a lot more effective. There was a reason they moved, and that reason is still there. Okay, and then there was somebody like Intel and Samsung that wanted play a little bit on both sides, saying we'll probably win. The fabless companies, of course, grew out at the ability to buy from TSMC, and it became this is very, very popular. I remember the good old days with Jerry Saunders of AMD said, real men have fabs. Of course, now Lisa Su can say, real women don't need fabs. Okay? But this was the thinking at the time. You're not a real man if you didn't have a fab. But today, most people don't have fabs. They're down in the fabless area. And then you have an interesting area here, what I call hybrid manufacturing. They play both sides. They have their own fabs for certain technologies and typically use the foundry for more advanced technologies. And this group of companies are quite important for Europe because we have three of the major ones here, and we don't really have some of the AI companies. And as you'll see, when I dive down to a little bit more detail, you'll see these companies experience the world in very, very different ways. So here we have basically broken it up. We have the semiconductor revenue broken up into the three models. And as you could see here, there's something dramatic going on here. This is from 2019, the beginning, to end of Q4. And as you could see here, two groups were down here, 21, with the IDM being, can you say, the most normal model. But now, this quarter, actually, or last quarter in Q4, for the first time, the fabless companies became the largest. So there's something dramatic going on in the supply chain. If we look at it like this, you can see that here I deduct the memory because it sort of clouds everything because it's memory pricing is a very, very big cycle. So removing memory, you get a different image. Okay. Now it becomes very obvious. Two of the three sectors in semiconductors are deep in the mud. Okay, so we are. This slide shows a completely different story than what you hear from the WSTS numbers. And by the way, the WSTS people are subscribing to my blog, and they email me angrily when they disagree with something. Which is something I save for Friday and a gin and tonic, replying to them, okay? But it's right now, already now, a few slides in the presentation, you could see that this is not everybody that are having the fun. If I add foundry into the equation, now I get a lot of angry emails on LinkedIn saying, you cannot, combine semiconductor and foundry into the same chart. And my reply is the normal one, I just did. Okay, so it's like you cannot compare everything, of course, when you do this, but you can easily compare. Here I show the relative growth from the beginning of 19, and you can see, of course, no surprise, foundry follows fabless because it's their customers. What's also worth seeing that is that foundry was ahead. Now fabless is ahead. So again, there something goes on. So this is not exactly breaking news. Even my hairdresser knows this, okay? Of course, these are the companies. And she'd ask, should I buy TSMC now? And it's like, oh, I don't do stock advice, I'm afraid. But of course, there are some dominant companies in each of these areas that really drive performance, but the rest are left behind. And these companies are not, they're not really important for our everyday life to the degree that the hybrid companies are. So this is the reality of the hybrid companies. Here I picked the most important ones, and as you could see, they're into a 10-quarter downturn. This has not happened before. Last was also long, it was 7 quarters, but before that, the normal downturn was about 4 to 5 quarters. So something is changing for these companies. And I may be telling a secret, but what are their CEOs saying? We're doing great, we're taking market share, the upturn is coming soon. Well, maybe this time it won't, or it won't be as powerful as it was before. Let's take a little bit of a deeper dive. So remember now, we're 2 years into the upturn. Let's look at the markets of these companies. Ooh, that's a funky kind of an upturn, Look at industrial there. If we could see this is massive. And if you think that, hey, I'm outside this, it doesn't bother me. The AI companies are sucking out all of the juice of the industry. Companies are shutting down production lines for stuff that keeps our gas boiler going. I can tell you this will impact everybody because everybody is running after the golden goose. Okay, the best performing sector is actually automotive. And I don't know if you know about the automotive climate in Europe right now. It's not. That's being very polite. So what is keeping up automotive? What is keeping up automotive? China. Yeah, EVs in China is keeping up automotive. Yeah, that's including China. Okay, so it's everything. So these guys are fortunate enough that they found a little EV in China that they could shovel in some nice components. But apart from that, it's quite a serious situation. So who are doing great? Well, the semiconductor market is turning into the data center market. So here you see the data center revenue over the last few quarters. As you could see, we have the cloud sort of revolution where Amazon grew and enterprises move their data into the cloud. It has a dip because there's a memory cycle, and then starts again here, a little dip. And at this point in time, it's about 14% of the total semiconductor market. It's not that long ago. It's back in 23. Now, Q4, it's 38% of the entire semiconductor market. One market. It's not happened before, okay? And this is not cyclical. This is systemic. So something is changing the industry quite dramatically. So I talked about demand a little bit earlier, so let me show you what the demand situation looks like. Traditionally, there's been two very, the main drivers of semiconductor revenue is that there's a consumer spend and there's some corporate CapEx spend. And normally they have been 50-50, and that's also what creates the cycle, because typically a DRAM gets very, very expensive, and then you look at the PC and say, oh, I'll wait with that. And 2 years later, it's like, oh, you can get it for free, then you buy one, creating the cycle. The corporate CapEx is a little bit more, a little bit less sensitive. Companies have long investment horizons and they decide over a longer period. But as you could see, the cloud sort of made the capex driver grow. And then we had COVID that turned it the other way. It almost got back into 50% because corporates didn't buy anything and we all built nests, oh, I need more flat screens. Oh, there's a wall over there, I need a flat screen. And, but that's what we did. So COVID really, really drove consumer demand. But look at this now. This is not cyclical. This is systemic. The complete semiconductor industry is under rapid change. And it's probably not going to stop this month. I can guarantee you that. So not only is it the data center that is sort of driving demand, there's of course a specific area inside the data center that's driving this. And I remember back when AI started, I talked to some people that are more technical than me, which is most. And they were saying, Claus, you don't understand. When AI comes, it will also require more CPU demand. Okay, so it's going to be balanced. And this might be true, but it did not help the companies that are supplying the CPU because revenue dropped 40% since the peak, while AI and GPU demand is 15x in that short period of time. Of course, if you have heard about Intel and CEO of the month, you understand that this company is in deep trouble. That's because that's one of their key areas. And it is happening at the same time as the PC market is sort of flattish. There's some AI demand coming, but it's been flat for quite some time. So Intel is right now pretty much in a perfect storm. Of course, they have Gaudi. Okay, that goes nowhere. It can't even hit $1 billion. So this is Intel's horror slide, this one. Okay? So let's try and find out, is this going to continue? Or are we at the end of it? DeepSeek. Oh, it stops, all this. Yeah, somebody's found out that Nvidia is too expensive. Yeah, Nvidia is too expensive, I got that. But there's a lot of arguments, but I listen to all of the calls of the cloud companies. There's no shaking. Their hands are steady and they're investing. And this is what it looks like. So what you see here is up until this quarter. So these are real numbers in the bank. You can see we are up at around 70 billion. And these are the plans of the top 4 companies. They, of course, are dominant in this area. But we will get it up to, we will be nearing 100 billion or something like that insane number by every quarter. This is how their, can you say, data center value increases. That's now at $800 billion. But more importantly, over here, you could see that the depreciation right now is 32 billion a quarter. That means the value of their server farms drops by this amount every quarter. They need to invest 32 billion just to stand still. Okay? You try and ask, we just have Blackwell, before we had H100. H100 workloads are not that popular right now. Now everybody wants Blackwell, and soon it'll be Rubin and what else is there. Every year, Nvidia will come with something new. So it's incredibly expensive business to be in. You got to run fast just to stay still. So this is for sure going to continue. You got up here 48% growth in CapEx. Do you think maybe Nvidia has something to do next quarter as well? I think so. They might take a dive because of China, but there will be plenty to do. And of course, you can get into the Oval Office for 500 billion. So I've called Trump and say, Semiconductor Business Intelligence is going to invest $500 billion in the US. We're going to open a branch there. And of course, I get invited. Yeah, but that's not included. But, next week he'll be in Jamaica and there will be a deal there. Okay. So what I do is, all I know is Trump is unpredictable. So somebody says to me, well, there's no tariffs on semiconductors. I said, it doesn't matter. There's no tariffs on this. It doesn't matter. Okay. He's making it unpredictable, which I love. Okay. It's tough for you guys, but for me, it's fine. Okay. So, but these are serious conversations that they have about spending this amount of money. And to be honest, Nvidia can do that. It's absolutely possible. So let's try and see what all of this does to the supply chain. So this is a kind of a very, very normal supply chain. We call it the good old days. It's a year and a half ago. Okay. So what you see here is you got foundry making die, you got a processing company buying it, you have a memory company buying some wafer and material. They both go to an assembly company and get it packaged. And then it goes to the server card manufacturer that can freely choose who they want to put into their server card. Of course, there are some companies that were strong in this area. You probably have to talk to Intel and maybe Samsung and SK Hynix. But the reality is that the server card manufacturer was the seller to the cloud company. Now, something's happened. Okay, it got a little bit more complex. So the first thing that happened is that now the foundry is very, very central in everything that goes on. Because not only does it deliver the dies, it also delivers the base die to HBM production, high bandwidth memory. And it also delivers the silicon interposer that you package all of the chips on. And by the way, they also do the packaging. TSMC does. So suddenly they become quite strong in all of this network. But it's nothing compared to the processor company. And here, talk specifically about Nvidia right now, but everybody will turn to this model quite soon. It's the only way to go. And now Nvidia controls everything. So they are now dealing with the cloud company. And you don't know what the HBM costs. You don't know what the GPU costs. All you know is what the Blackwell costs. That means these are the most expensive screws in the world. That chassis is expensive. Okay. So this dominance is completely rearranging the not only the semiconductor industry but also the server industry. So let me show you. When you talk to WSTS and other companies like Gartner and things, they put Nvidia in the semiconductor category, which is kind of entertaining. I don't think they sell semiconductor devices anymore. They sell GPU boards and then they sell full servers. So this is Nvidia's revenue model. So yes, they are selling some stuff. Here you can see GPUs and network. There's Supermicro. They have their own manufacturing. These guys use ODMs, and Nvidia, of course, use ODMs. These guys are quite interesting. Inspur. If you ever want to take a look at them, just try and take a look at them and see their revenue growth. They are the key. Can you say supplier in China of AI based on the H20 from Nvidia that they made to downscale it to avoid all of the embargoes. But what you can see up here is this is the most interesting part. 16.7 billion of Nvidia revenue is now servers. You can call it devices, but they're 3-ton devices. Okay, I'm okay with that. And that's where, WSTS and I have a little bit of an argument, and I'll just keep it here. But this is a completely different business model now. Also, the problem is, of course, that these companies have sold HBMs to Nvidia. Okay, so WSTS reports this, and now it's sold again over here. This also reports. Okay, fine. It's just a billion here, there. Doesn't matter. Don't worry about it too much. So this one down here is quite important because it's also important from a political perspective. The ODMs are big companies. It's not easy to move this. There's a complete, very, very nice supply chain in Taiwan. And here I just showed you from a revenue perspective. My apologies. I haven't updated this slide. It's from Q2. So what we see here is Nvidia is somewhat bigger, and so is Samsung. But TSMC, but it's the same idea that a company like Foxconn or Honhai it's not easy to replace. They have 800,000 employees. That's more than the other companies combined. And the whole concept behind the reshoring to the US has a slight problem in this area. So let us try and look a little bit deeper into the Nvidia numbers here. There we got the Blackwell, nice little box there. And you can see that it's not a new thing that if you decide that Ampere is really a server, it's maybe a card. I treat it as a server. But one of the things that's happening as well is that Hopper is only, a little over a year old, and it's already dying. Blackwell is coming. Okay, so now this for almost 40% of the entire semiconductor industry needs to reinvent itself every year. It's massive pressure on the supply chain. Okay, it's not fun being some of these companies supplying to Blackwell. Nvidia's purchasing backlog is over $80 billion. So they basically bought the supply chain. So if you hear stories like, oh, this company is going to compete with Nvidia, yeah, maybe they have the technology, but they won't have the products because Nvidia's already bought them. So this, of course, means that Nvidia is now much more a server company than it's a device company. And it's ripping the old server industry to pieces. So basically you have Nvidia here, is now the largest server company in the world. Servers, actually the standard servers have been pretty resilient. But you of course can see the AI driven, is here. When you look at them in count, it's not a lot, but it's expensive. Okay. So this is what, basically skews the entire industry. The other funny thing is, of course, the growth of all of these companies depend solely on AI and the supplies from Nvidia. The supervillain said, okay? Nvidia decides this entire industry. They decide who should have what, when, and for how much. And now I think they've been competing a little bit too well with ourselves, so let's stop that. So prices can go up. I'm not saying they're doing that. I'm just saying if I were them, I would. And it's not only, can you say, just the GPU companies. If you look at the leading memory company, which is now SK Hynix, this is what, can you say, their revenue by area looked, can you say, back in the 19. Now, the combined server and AI compute is now at 71% of their revenue. Okay, so memory are used elsewhere. There's also something called industrial memory. Okay, how much is SK Hynix going to spend on that? How much time? They're going to hunt the HBM, and right now they're ahead. And even when you listen to the investor call, they're saying, we are not a commodity company anymore. We are exiting the memory cycle. Oh, okay, sounds interesting. And that's their serious plan. But it means a lot to the rest of the industry. Suddenly, we might not have access to this kind of technology because everybody is hunting the golden goose. So this is worth bearing in mind. Tariffs, embargoes, and other growth strategies. So I've been following this for quite some time. And I can tell you, my opinion is that tariffs never works, embargoes never work. Actually, often they do the opposite, but they do have an impact. So it's not like it's irrelevant. They do change things, but it's rarely what they were intended to change. So let me just show you what the CHIPS Act looked like. So this is a lot of money. The whole bucket is close to 55 billion. Of that, a sizable chunk is for direct manufacturing. And as you could see, a number of companies have taken the big chunk of the money. There's some more later on, but these are the biggest companies. And you can see basically all of them are in one shape or form looking at the data center market. So all of the CHIPS Act money are basically being plowed in, or most of it are being plowed in to the AI market that's already at 38%. Or the data center market is already at 38%. It's going to get some big vitamins over the next year, and it's starting to show. So what I'm going to show you now is the overall capex of all of the semiconductor companies, and it actually peaked right around when the CHIPS Act were ratified. And interestingly, at least I found it interesting, but I don't have a life, is that it actually were supposed to increase capex spend of companies, but it didn't. Actually, it declined. And first I thought that is completely, counterintuitive. But later on, of course, I found out that all of these companies stopped their investments. Okay, brakes on. We got to get US chips money, and then we got to relocate to the US. So actually, it did make sense. And you could also see the effect here now. That actually now you see that the money is being spent and the factories are being built and they're being filled with expensive toys. And you probably also know that a very high proportion of semiconductor capex are spent on semiconductor tools. And this is what is spent on tools. So this is what keeps me up at night. So it's like, this one goes down and then up. This one goes, why doesn't it go down? It should. Who are they selling to? So, of course, we need to go deeper. And this is what you see here. This is semiconductor tool sales by country. And here I've excluded one country, and you do indeed see the dip. Okay, this is exactly the way it should be. And now let me add the last country. So, of course, our friendly purchasers in China are absolutely willing to buy our expensive toys. And during the last 2 years, they have basically peaked around buying 45% of all Western tools. Okay. Now they're a little bit lower here the last few quarters. There are more embargoes. So they're probably right now around 30. But there's a lot of tools and they're not in production yet. So whatever impact China has right now, wait until Christmas. They got some presents for us. And they can't sell them in the US right now, so they might be cheap. Okay, so this is really, really serious, and it's going to impact the entire industry. So you think AI has just disrupted it? Well, there's more to come. Let's look a little bit about the supply network. So my apologies, but this is done by country of incorporation, not by actual location, because that's a little bit difficult to have. But what you look at here is that you could see that Taiwan is really dominant in a lot of industries, maybe except tools. US very dominant in the companies, but less so in a lot of the others. And down here you got electronic manufacturing, where they're basically not there. So what I say is, you have places to place a fab, bad, worse in the US. Okay, because what they're talking about is they want to bring semiconductors back to the US from where? From Taiwan. Oh, okay, we do that. So where are we going to ship them? Back to Taiwan, because they need to be manufactured in a Taiwanese fab that send it to China, back to Taiwan, and then back to a US customer. This makes no sense at all. Okay, so you see that of course some companies are thinking about bringing that back as well. Well, good luck. Let's see how that works out. But it's really the worst place to place a fab. And Maurice Chang knew that when he started TSMC in '87. He knew it was the worst place. And they could get all the customers. And it's still the worst place, no matter how much money you pump into it. In the US, you have whole cities that are now Taiwanese, because US workers couldn't operate the factories. They want weekends. They want to go home at 5. Come on. And the suppliers did not come out in the weekend and stuff like that. Doesn't work. So TSMC basically brought a lot over there. So it's quite an expensive place to operate fabs. So let me show you what has happened in TSMC. So right now they have, this is their plan. They've just upgraded US. They've added 4 more facilities to what they originally wanted to do. They want to make sure that Trump protects Taiwan, so he got a little bit extra. So right now they have 8 high-cost US facilities that is in progress. You can see the 4 nanometers starting to spit something out now, but it's not a lot. And eventually it'll be, just one generation behind Taiwan, as I told you. This is the rule. In Europe, we get a little bit of a specialty fab just, so they can visit, and a couple in Japan. But these are expensive. So of course, what do Taiwan do to offset expensive factories? Well, they build some at home, only a few. Okay, so this is what's currently planned by TSMC. They have 15 factories in progress, approximately 2 per US fab, to offset the cost. 9 of them are going to start construction this year. Okay, this is pretty horrible, wild, crazy. I don't know what to call it. This company is something special. I sound like a shareholder. I cannot comment on that. So the question now becomes, is more capacity needed? because we are in an upcycle, and in an upcycle we should be pretty close to full capacity. We're 2 years in, so let's try and find out who should we call. Let's call TSMC and find out how they're doing. Okay, so what you have here is their capacity. This is measured in 12-inch equivalent. Basically, you just its area, silicon area, and as you could see here, their shipments sort of intercepted. You had full capacity in this range here in 21, 22, and then it dropped off. But capacity kept growing. Right now, the utilization rate is at 73%. Okay? And this is at the wildest time in the semiconductor industry, the highest revenue ever. And TSMC is at 73%. And they are carrying the entire part of the logic part of the AI revolution. This is insane. Okay, so question is, do we need more? You probably guessed what I think, but we will keep tracking it. So here you see TSMC's manufacturing by node. So up here you got the 3 nanometer node. This is basically Apple that's taking most of that. Here you see the 5 nanometer, which is also the 4 nanometer that Nvidia uses. But what you look over here, you look at revenue, and then you try and compare it to the number of wafers that are actually manufactured. This is not a lot. Look at that, and look at that over there. And look at that, and look at that. Okay. So these wafers that TSMC are producing are incredibly expensive, but there's not that many of them. And Nvidia is not selling many GPU chips. They're selling them incredibly expensive. So what looks like an upturn in reality is a price increase in a lot of different market areas. We maybe should take a look at one of the memory manufacturers as well. So here we got Samsung. So quite interesting, you could look at Samsung's material purchases. So, how's that going? And during the last cycle, you could see that it went up like that. But where is it now? There's nothing for the supply chain. They're sitting there saying, yeah, everybody's buying DRAM. No, orders are coming soon. Sorry, maybe next month. Okay, the supply chain is not seeing this. They're flat. Their margins are down. They're struggling. Of course, you could see that the capacity goes up a little bit. That's more, new technology and stuff like that. But what you also see is they're running at full capacity, also in the downturn. So basically, you have here that Samsung is running at full cap, but it's not actually producing much more than they did in the downturn. Again here, we got a situation where there's zero nutrition for the supply chain. And actually, it's not growing in reality. Then we look at the top 5. I call them the EUV clients of ASML, because to get an understanding of where they are investing, and you can see they're all investing in leading edge, and it's revealed by ASML's share of the total capex of these companies. From a few percent, it's now close to 8%. 8% of all capex is spent on expensive light and magic tools from Holland. Okay, there's an amazing amount of new capacity coming online, and it's going to be Spitzenklasse for sure. So what about the more mature capacity? So what you see here is the capex of the hybrid companies. Before we saw that they have a revenue peak in Q3 22, but their investments kept growing. Actually, of course, there's a delay before they can respond, but actually it's still at a pretty high level. And you look at a company like, I don't know where Wolfspeed gets their money from, but they're spending 500 billion. It's probably 3x their revenue. Okay, this is insane. But there's also a lot of mature capacity coming online. And these companies are still 10 quarters into the tank. So it's completely insane. So let's get back to China. So here we see this is the internal manufacturing of tools in China. As you could see over here, it's still a relatively small proportion of the total tool sales. But if you look at this line here, this is about 50% CAGR. This is insane also. They're building a lot of tools themselves. They don't want to rely on Western tools. Of course, here you now see the new uptick, but China is really, really going to come with a lot of serious capacity very, very soon. Can we see it? Yes, we can. So this is semiconductor manufacturing in units relative to the beginning of 21. So you could see now that basically in that period of time, the output is now 60% higher than it was before. And then if we look at all of the markets that sort of the Chinese have, they're not doing that well, okay? So, the best industries are sort of like 10-ish, over a 5-6 year period. And some of them are in the tank. They're still, negative. So China is producing more semiconductors, but all of their markets are down. So what's going on? So what's going on is that China is conquering their own supply chain. So, before, even the Chinese companies had a very low percentage of Chinese components in their products. Now they have a much higher percentage of components in their own products. And who used to sell them this stuff? The hybrid companies. Okay. So these companies are waiting for an upturn. It's not going to happen, I think. Or it's going to be smaller than they expected. Or maybe it's going to be later, because the Chinese are really, really conquering their own supply chain. And what do you think happens when they've finished conquering their own supply chain? Next country, Europe, come on, here we come. And they're already here, but we will see them to a much larger degree. So we are getting close to the end of the presentation, but I hope that you now can see that, yes, it's more than just looking at the WSTS number that tells us that we're 2 years into an upturn. The semiconductor industry is truly changing, and it's not going to stop this quarter. It's going to carry on. The sort of spiel of the Trump administration is that, okay, we need to have the semiconductors in, and somebody tells them, well, then you have to send it back to Taiwan. No, that's not good. So let's move manufacturing as well into the US. And then they're sort of saying, well, but how are you going to manufacture? Yeah, well, we're going to automate it. Okay, so you're going to bring the jobs back, and then you're going to automate them. I don't know. Sounds a little bit silly, but okay, leave it at that. So how are you going to, automate it? Well, we're going to build robots. Oh, okay. So who are going to build the robots? So let me just show you what else goes on in China. Here you got the semiconductor units down here. We were about 60%. So let's see 2 other areas where China is being quite busy. Okay, that is the number of industrial robots. Already now they have the largest installed base. Now they're starting to build them themselves. If you look at industrial robot sales in the rest of the world and the Western manufacturers, their sales are flat. Okay, yeah. What? Yeah, run marathons for sure. They do. And the other important things are power generators. You need power for all of this. So basically, China is 1 step ahead. Okay, and I would not say it's stupid to compete with China. No, there's issues with China, but everything the US have done have worked the opposite way. China is a lot stronger than when all of this started. They have more semiconductor manufacturing, they have better tools, and they're preparing for the long game. While US companies are still jumping from quarter to quarter. 13 weeks, don't worry about next quarter. We got to deliver this one. Don't worry about it. I've been there, done that, done my tour of duty. So basically, it's time for conclusions. And these are my conclusions. And again, you don't have to agree with those. But, if you want to disagree with the foundations, just let me know. But this tide does not lift all boats. The cycle is broken, and it's been replaced by many cycles, of which some are not cycles. They're just downhill to the bottom very, very fast. There's no nutrition in this cycle for the supply chain. And many companies are delivering to these large companies, and they are I have several of them as customers, and they're just asking me, what's wrong? And this is what's wrong. Your market is not growing. Something else is growing. And I think the hybrids are, I call it the death spiral. This is maybe a little bit tough, but there are two of those companies that I think are terminal. I will not mention who they are because I don't know if my opinion matters that much, but they'll not be happy with me. But there are two that are in serious trouble. Also because of the way that they behaved maybe in the COVID cycle. And then there's a lot of capacity coming. You know who they are. But is it needed? Again, this is a question. I do analysis, not forecasting. I just think that all of the numbers show that that's very doubtful that we need this capacity. And I think we're heading to something I would call maybe the 2026 super cycle, and it will not be up. It will be down. And what you also can see from this is that China has conquered its own supply chain, and it's getting ready to conquer yours. Okay? With that, I'd like to say thank you, and I hope you've enjoyed it. My chart attack. And questions? Dear Foreman?
Oh, okay.
Yeah, we had a discussion at lunch actually about the Chinese semiconductor suppliers and whether the European manufacturing base are willing to take the risk of even buying them from quality perspective, maybe, and also what if Trump says that Europe, you're not allowed to buy anything from China, that's it. So what's your take on that?
So I think if you look at China, we have this concept of poor quality. And I think the CEO of Apple, Cook, said it best. He said, "We're not in China because of price, okay? We're in China because of quality." And because and the same with TSMC, they cannot get that build quality in the US. It's simply not ingrained. So I think that's the first thing we need to realize. Are they behind? Yes, but not a lot. You heard Jensen Huang here recently say that actually they're only very, very little behind us on AI, even though they don't have the same, can you say, technology. And if you look at DeepSeek, okay, this was made on a tight budget. And I think it was Marissa Mayer at Yahoo that said, or maybe somebody else that said, scarcity is the friend of innovation. You have to be creative, so something like that happens. So I think it is close to European quality, okay? And the European companies are already placing some of their manufacturing in China in order to look Chinese so they can sell to the Chinese. They already know this. So I don't think it is. I think it's going to happen because in the Western world, we saw Microchip close some manufacturing facilities, ON closed some. They're basically loss-giving, so they throw them away. And that there's somebody who used that capacity. So you're used to buying these mature products in the US. Well, you can't buy them anymore. They're obsolete. So what do? You buy them, the only place you can buy them from, that's China. So I think it's maybe not just a choice anymore. I think we're being driven in that way because we play the quarter or between vacations and they play the decade. So I think we have to get used to calling China to buy some of these components. I think that's, and quality, already now quality, I think it's good. Memory companies are struggling because they're one generation behind them. Does that answer the question? Good.
And you can catch him afterwards with your table, which is number. Do you have a table number?
I don't know if I have a table number, but I'll stay near here, maybe just out there. So anybody want to come out and have a chat with me, please do.
Okay. Thank you,
Thank
Claus,
you very much.
Thank you.